Here we're going to look at number 17. Alex can cut the grass of the backyard by himself in 3 hours. If Alex works with his brother Bob, it takes only 2 hours. How long would it take Bob to cut the grass if he works by himself? So we start by answering this question. Remember to use the four-part paradigm here. The first part is to write the answer. It would take Bob T hours to cut the grass. And then in step 2, we're going to write the equation. In preparation for writing the equation, let's make a table. So in this table, we have Alex, we have Bob, and then we have them working together. In the first column, we're going to put the time it takes to complete the job. The time it takes to complete the job for Alex, if he worked by himself, is 3 hours. Bob, T hours, and together 2 hours. In the next column, we're going to write down part of the job done in 1 hour. So if Alex takes 3 hours to complete the whole job, then in 1 hour he's done 1/3 of the job. If it takes Bob T hours to complete the whole job, then in 1 hour he would have completed 1/T of the job. And together, if it took 2 hours to complete the whole job, then in 1 hour, working together, they would do 1/2, half the job. And so this sets up your quantities that you add up to get the equation. So in 1 hour, Alex does 1/3 of the work, plus Bob does 1/T of the work, and together they're going to complete half the work. And that gives you the equation. Now to solve this equation, which is step 3, you're going to multiply both sides of this equation by the LCD, which is 60, and simplify. So we get 2t plus 6 equals 3t. And so subtracting 2t from both sides, we see that t is equal to 6. So therefore, in step 4, we can write the sentence again. This time, in step 4, instead of t, we can replace that with 6 hours. So it would take Bob 6 hours to cut the grass if he worked by himself. Okay, let's look at number 18. John and Lily row their canoe 26 miles downstream in 2 hours. After a picnic, they row back upstream. After 3 hours, they only travel 15 miles. Assuming that the canoe has a constant speed and the river's current is constant, find the speed at which John and Lily can row in still water and the speed of the river's current. So we have two things we have to find. In number 1, we're going to write the answer. So the speed at which they can row is x, and we'll do that in miles per hour. And the current, the river's current, is y, miles per hour. So we're going to have to find x and y. Now, in part 2, we're going to write an equation. In this case, actually, there's 2 unknowns, so we need 2 equations. But before we can do that, let's think about the basic formula of uniform motion, which is distance is equal to rate times time. So in the first part of this sentence, we say that 26 miles downstream in 2 hours. Now, downstream means that they're going with the current of the river, which means they're going to be going faster. Without the current, they can row X miles per hour. So with the current, their rate would be X plus Y. The current adds to the speed that they can row. The time is 2 hours, so times 2 equals the distance is 26. So that's the equation we get from that fact. The next fact is they row back upstream. And it takes them 3 hours, but they only go 15 miles. So in that, upstream means they're going against the current. So the current is going to slow them down, so we subtract the current, the river's current. So that's the new rate, upstream. Multiply that by 3 because time is 3 hours, and then the distance traveled is 15. This second equation comes from that second fact. Now let's simplify these things. We can actually divide the first equation by 2, and we would get x plus y equals 26. Or both sides we have to divide it by 2, right? So this would be 13. And then the second equation will divide both sides by 3. We would get x minus y equals 5. And now we have a system of equations that we can solve. That's part 3. Okay, so in part 3, here I'll label this as a and this as b. So what I'll do is I'll do a plus b to eliminate y. So that would be 2x equals 18. So x is equal to 9. And then I'll substitute for x in the first equation, a, to get 9 plus y is equal to 13, or y is equal to 4. And that solves the system of equations. Maybe we can put this up here. Okay, now in step 4, we can go back to the sentence we wrote earlier and rewrite this sentence. But instead of x, that's the speed at which they can row, that's 9 miles per hour. And instead of y, that's the river's current, that is 4 miles per hour. And that solves the problem.